Then problem is if integral 0 to 1 x to the power of m into 1 minus x to the power of n into dx is equals to capital R into integral 0 to 1 x to the power of n into 1 minus x whole to the power of m into dx. And then here the options are, first one is a capital R is equals to 1, while the second option is a capital R is equals to minus 1, while third option is a capital R is equals to 1 by 2, while the fourth option is none of this. Now we are going to check the values of R according to the options. So clearly it says that the lower limit is 0 and upper limit is 1 in both the cases, that is LHS and as well as RHS. Now, in order to evaluate the problem, we have to assume that the 1 minus x is equals to y. So the very first step is put 1 minus x is equals to y. So when we take 1 minus x is equals to y, then we can write it as differentiating on both sides, 0 minus dx is equals to dy, or minus dx is equals to dy, or dx is equals to minus dy. Now with the integral value that is in the LHS, we will assume it as I. Then this can be written as, let I is equals to integral 0 to 1 x to the power of m into 1 minus x whole to the power of n into dx. Now we'll change the lower limit and as well as the upper limit, so that this can be written as upper limit is y is equals to 1 minus x, that is equals to 1 minus 1 is equals to 0, whereas the lower limit is y is equals to 1 minus x, that is 1 minus 0 is equals to 1. So this can be written as I is equals to integral, the lower limit is 1, upper limit is 0, x value is written as 1 minus y whole to the power of m, 1 minus x value is y to the power of n. In the place of dx, we'll write it as minus dy. That is, minus is a constant, we'll get outside of the integral. Minus integral 1 to 0, 1 minus y whole to the power of m into y to the power of n into dy. Then I is equals to this minus, if you remove, then the lower limit will becomes the upper limit and upper limit will becomes the lower limit, that is integral 0 to 1 1 minus y whole to the power of m into y to the power of n into dy. We know that the formula, that is integral a to b f of x into dx is equals to integral a to b f of t into dt. So based on this, this can be written as integral 0 to 1 1 minus x whole to the power of m into y to the power x to the power of n into dx. Then we can say that by comparing r is equals to 1. That is known as first option.